name is Nuno Neves. I'm the co-founder of CRAFT4.0, and we dedicate ourselves to advanced engineering, manufacturing, and additive manufacturing. CRAFT4.0 started 10 years ago as a company which installed industrial production lines all over the world, and slowly we started pivoting into additive manufacturing and more advanced engineering. Our clients are composed of mainly independent designers and engineers, as well as large multinational companies with projects which range from production to final products. If the only thing that a client has is an idea, we basically take this idea, we work with them from the initial sketches to the final business plan to how they're going to market and how they're going to patent their idea. The AMS Mini came about from a project that we had 7 years ago. This project consisted of a painting line, which is 16 meters long, 3 meters wide, and 3 meters high. The main challenge that we had was fitting all the technology into a small package that fits into something the size of a basketball that you would have in your hands. We also felt it was very important to design for a purpose, which is to purify air, but also to distract the mind of the final user from its purpose. So it's a medical device which doesn't look like a medical device. It's something we designed to be admired, something to be beautiful, because in the times that we live, it's very complicated to have all these sanitizing industrial equipment inside your home or inside your office, and it's very different if you have something that was designed to be looked at. So it's designed for something that's very cold, but it's not a cold product when you look at it. The AMS Mini, the solutions that we were looking for was to have a system that's exceptionally small but able to produce a lot of airflow. We looked at a lot of different possibilities, including HEPA filters and large displacement blowers, but what we found was that if we use the correct components and the correct geometry inside the actual unit, we can compact it into something exceptionally small and increase the airflow. We designed the AMS Mini because we felt that there was a need on the market for an actual quality product. Normally everything that we see are products that come from China, they're not tested, they're not certified. The AMS Mini is made in Europe, it's made here in our installations, all the parts are sourced locally, nothing is imported from outside of Europe, and we felt that this was exceptionally important in order to be able to guarantee our customers quality. Quality in its manufacturing, in its texture, how it feels in your hands, how it looks on a desk, but also quality that we know that this machine is working 100%. The reason that we used panots in the exterior design of the AMS Mini is because it's a product designed in Barcelona. We always try to inspire ourselves in the architecture of the city. It's actually quite a wonderful place to walk around and see. The Panot design is excellent because we take a round cylinder and cover it in a square pattern. This gives us a lot of game as far as the texture, how it feels, how the light hits it, and it plays a lot with shadows. The Panot Style is something that's very unique to Barcelona, and we try to use this as much as humanly possible. In itself, the top of the AMS Mini was designed based on the Roman ovens, which we have here in Vilassar de Dalt on the other side of the street. The pattern is exactly the same. So we took two different inspirations into one product, and the fact that we do use additive manufacturing, we can customize it any way the customer desires. The order in which we reach our concepts, we always start with hand-drawn concept drawings. The reason we draw things by hand is because one thing is when you start something in 3D on the computer and you look at it, it's okay, it's a good process, but usually wind up doing a lot of different models. When we draw something by hand, we actually take the time to think, to sketch out the shadows, to look at the proportions, to look at depth. And as we do it, you become more emotionally involved in what is the actual final product. Once we're happy with the sketches that we have, that sometimes it's an entire notebook full of sketches, once we're happy with that, then we start the 3D process. First we do what I like to call a concept design in 3D. So the concept design is basically its outer shell, and this is more or less how it will look. With this, then we use our rendering technology to put it inside rooms, to put it inside the area where it's going to be, to see how it looks. We can also play with different light points. Once we're happy with the exterior design, then we take it to the next level, and that's where we start doing the serious engineering. Sometimes the final design changes a little bit because you need to make it wider, you need to make it higher. Sometimes the electronics that you want to use don't fit inside, you need to figure out how to package it inside the unit. But normally within 90%, it's more or less the same. From that first design that we did by hand to the final product. The fact that we use additive manufacturing with our equipment in-house allows us to jump several steps. So you have the handmade drawing, you have the 3D drawing, and from here, instead of making prototypes out of foam or silicone, we can go directly into a 3D prototype, which is already functional. Based on the tests that we do with this first initial prototype, we then go back, redesign anything that needs to be redesigned based on the numbers that we were able to obtain from our tests. And then from here, it's already final product. Once we have a 3D design already made and validated, it takes us about 16 hours to print and 72 hours to cool. So we can usually have a project within 3 days that we can already feel. Like you hold it in your hands and you can test it. Both the prototype and the production design are made out of PA12. It's a type of nylon, which is very chemical resistant and resistant to UV light. We also used a lot of titanium dioxide, which we use in a resin as an interior coating, and this both protects the inside of the unit as well as is the catalyst for a photochemical reaction. Going from prototype to final customer product, we didn't face a lot of limitations because since we use additive manufacturing and we're able to adapt things very, very quickly, we were able to do all the changes that we needed based on the information that we had and manufacture the final customer product. So we didn't have to go through a lot of different phases where you make a prototype, you test, you make another prototype, you test. So basically we went from beta to alpha within a period of days. Additive manufacturing is used in the final customer product. We do this for several reasons. One, there's geometries inside the unit which we can't do with injection molding. It's exceptionally complicated and expensive. We also offer our customers the possibility of customization. So for example, a bank or a hotel, instead of having our normal Panot Style, can have their logo or can have something which identifies their city or their business image. Everything is exactly the same as the prototype because additive manufacturing can be used as a tool for your prototyping and then production is done in a different form. No? But when you design something from zero to be made with additive manufacturing and not have any restrictions as far as the geometry of the actual product, additive manufacturing is actually quite competitive compared to injection molding or compared to rotomolding, for example, which would be one of the ways we could do the exterior of the product. But it takes away strength and it takes away customizability for the customer. Each AMS Mini is manufactured by hand. We didn't implement automated processes to assemble it. We do this because we want each individual unit to be different, to be its own. So the customer owns one that's not like the next customer. Hand finishing also gives us a type of style and texture which you can't duplicate by automation. We first started setting up a network of distributors all over the world, in Europe, South America, Africa, and the Middle East, in order to distribute the AMS Mini. These distributors already normally distribute medical products, so they have an understanding of the product and they have an understanding of what the product is supposed to do and are able to transmit this to the final customer. Typically right now we have a very strong market in South America and the Middle East. We are also working with one of the largest banks in Africa for them to install AMS Minis inside their banks to protect both employees as well as the public that comes in. The publicity that we made, we basically sent out a small press release. It was published in Italy, in Spain, in Russia, in the United States, along with several other magazines which contacted us in order to receive more information, and each made their own article based on the product that we were launching at the time. We're quite happy right now with the way the public has been receiving the product, especially in the Middle East and Africa. We have a lot of people which value their health over other things. If you think about it, the home costs less than an iPhone, you know? So it's everybody's priority as to, you put your health first or something else first. But we're actually quite happy. We think that in the future, the units will be moving quite well. Again, in Africa and the Middle East. And we'll see what the future holds.